who wants to give all of you the necessary tools and skills to find innovative solutions to the new problems we are facing every day. How do we want to make it? By learning more about nanotechnology and solutions that are being researched nowadays. Once you know how science is working on these topics, you'll learn how they can be mixed with arts to let your creativity thrive. All of us use electricity on a daily basis. This current that goes through our cables is based in electrons' movement. Those electrons behave like our planet. They rotate, and that rotation gives them momentum. You may not understand it fully right now, but in a minute I'll show you a demonstration that will clarify things a bit. This movement helps them to keep themselves still, like our planet does. However, they don't have to share their spin with the electrons nearby, meaning each of them can be facing different directions. When all of them face the same direction, we can appreciate magnetic properties in the material. But even though these materials don't have magnetic properties, it's important to know how magnetism works, as we'll see in our demonstrations. But the main question is, what are spin currents used for? These currents allows us to send charge and spin information, which is extremely useful for quantum computing. And since electrons don't need to move, they can go through insulators, which can be used to harvest energy. We talked about a lot of things already, but we want you to understand spin currents. So let's start explaining what a spin is. We said that electrons move like our own planet does, meaning they rotate over themselves. To understand a little better how this movement can affect them, I have here a gyroscope with me. And there we are. And when we make it spin, let's see, you see, it remains still in place. As you can see, it remains still in place. And we can even push it, throw it, and it will still keep in place, in position. If we were talking about an electron, we would say it's keeping its spin. Now imagine hundreds of gyroscopes like this one all together but facing different directions. And when we make them go under a magnetic field, they all align, even if it's momentarily, like it happens to non-magnetic materials. Talking about non-magnetic materials, here we have aluminum foil. As we can see, the magnet doesn't stick to it, you see? But look what happens when we throw the magnet inside. As you saw, it took more time to go through it what we could think at first thought. Let's see another example. When we place here this little tiny boat made out of aluminum foil, and we move the magnet around it. Let's see what happens. Even though it's made out of a non-magnetic material, you see? It moves a little. In both cases, what happened was a process called electromagnetic induction. Despite aluminum not being magnetic, when a magnetic field moves around it, the electron spins, move momentarily and retain the magnet for a bit. This electron movement can be passed onto the spins nearby in a really particular way, creating a wave-looking movement. We are going to create a model to see how they move in real life. You are going to need the following materials. 20 straws, which will represent our electron spins, scissors, yarn, a piece of cardboard, a nail or something to puncture, ruler and a pencil. if your straws are bendable, we cut them before the bendable part and we save that part. There we go. On the cardboard, using the pencil, we mark the extremes of each straw. And we measure the center of the straw. And then make two holes that are 1.5 centimeters apart the center. There we go. Apart from each other. And we will use them that way. Now that we have all the measures in our cardboard, we repeat the same process in all straws. We take one of the saved parts and we pass it through the yarn, and then we pass the yarn through the first straw. Then we take another saved part and we cut it in half. There we go. And we pass the yarn through each of those halves and then put another straw. Now that you have your models, you can see you have all the electrons, I mean straws, with a specific spin, and when you make one of them go under a magnetic field, I mean when you push it, it sends the current to the nearby electrons. Those are the fundamental principles of quantum computing. By researching more about this kind of currents, we will be able to be more efficient devices and develop a whole new informatic era. I'll see you on the next Eurocard video. Keep experimenting!